Lesson 13.8 is compound interest. So you might be wondering, what is compound interest? When you're compounding something, you're putting it together. So compound interest is when you earn interest, you're earning money on both the money you've saved and the interest you earn. And so if you put $100 in and it's earning interest, that interest will tag on top of the $100, and then you'll earn more money on top of that, and on top of that, on top of that. It's compounding, it's putting it together. So this formula is a little lengthier. I went ahead and told you what each variable is. So A is the final amount. That's like our Y equals. P is our principal. The principal, not like of the school. Your principal is the initial amount. We've seen this here first in all of these equations. Then this looks similar to exponential growth because it kind of is. It's 1 plus the rate as a decimal divided by n. N is going to be the number of times it's compounded in a year. So that's the words like it's compounded yearly. That would mean once a year. It's compounded semi-annually. That means twice a year. Quarterly, 4 times a year. Monthly, 12 months in a year. Daily, 365 days in a year. Weekly would be 52 weeks in a year. I'm wondering what of this you remember, but n is the number of times, and then to the exponent you have your t, your time, but times how many times it's compounded. So if something is compounded monthly, it's 12 months in a year for 10 years, and that makes sense that you multiply to say how many times is it actually getting compounded. So let's try it. Alexander invested $320 in an account. It paid interest rates of 1.5% that was compounded annually. Assuming no deposits or withdrawals are made, how much money to the nearest $100 would be in the account after 18 years? So to find the final amount, you could put Y equals. He started with $320 times 1 plus the rate. Even though it has a decimal, I still need to change it into an actual decimal, which is not a percent. Move it 2 places to the left, so that's 0.015, divided by how many times in a year? Well, this means n is going to equal 1. So divided by 1, which won't change anything. And then if it's doing that for once a year, after 18 years, then it's going to be 18 times. And so really, this looks just like a exponential growth. So that'd be 1.015 to the 18th power. Might be better to put parentheses here so you don't think that's a decimal. Okay, 320 times 1.015 to the 18th power to the nearest, what'd it say? $100. Well, that's 400, so it's either going to be 400 or it's going to round up to 500, which would be 400. Kind of a weird, okay, that's kind of a weird, to the nearest 100. Okay, whatever. All right, number 2, Jaden invested $65,000 into an account paying interest at 2.1%. It's going to be put together, or interest on top of that, quarterly. That means 4 times a year, just like your 4 quarters in the school year. Assuming no deposits or withdrawals are made, how much money to the nearest $10 would be in the account after 7 years? So the final amount will have the initial amount times 1 plus the rate, which is 0.021, divided by how many times that's happening, 4 times in a year. So that 4 times in a year for 7 years, that would be 4 times 7, or 28 would be our power. So you could do this all at once. I do really like taking the 0.021 divided by 4 first, getting that as a decimal, and then adding 1 to it. And then taking that number to the power, because remember, exponents come before multiplication. And then times 6,500. And so it's that. And so nearest $10. So tens, that's either going to stay 60 or it's going to go up to 70. Well, it's just a 4, so it's going to be 60. $75,260. And last one, Kennedy invested $5,000 in an account. It's paying interest rate of 6.4% compounded daily. We're not talking about leap years here. We got 365 days in a year. There's going to be no deposits or withdrawals made. So how much money to the nearest cent would be in the account after 15 years? So starting with 5,000, 1 plus, change percent into a decimal, 0.064, divided by n. And then it's going to do that 365 times every day for 15 years. So I would do 0.064 divided by 365. Oh man, plus 1. Okay, I'm not even going to write this down if that's okay. I'm just going to keep this answer going. So right now I've got this part. I'm going to take it to a power, and it's going to be to the 365 times 15 power. The only thing I'm afraid of, if your calculator does not float this up as an exponent, you might have to put parentheses around it so that it knows you're wanting to take this times this in the exponent. And then that will get this whole thing, and then I'm taking it times 5,000 bucks. And so now it's $13,057.38 because it said to the nearest cent. And so that is compound interest.